So do mic check. Good evening. Good evening, little peeper. You beat me to it. Good evening, everybody. Hello. Glad you're here. For those of you who are here, if you're watching it later, hello to you as well. All right, thank you. So I hope everyone's had a good start to your week. For me, we're starting to get into the fun stuff of our semester. So, good evening, Tyler. So I've been looking forward to getting past that first project, and then we can start getting into the real meat of our work. Hello. So, hello to everybody. Now can I see you in chat? So some of you can see in chat. Anyway, welcome. Glad to see you, or glad for you to see me, I guess. Okay, so I'll just I'll look at our schedule just to remind you where we're at, and then we'll jump right into a thing. So what I'm going to need for an example, so you can start thinking about it, is some sort of class or category of objects in the world that seem like it would be natural to sort them by size, by weight, by color. That's kind of what we're going to do here. Is we're going to build up an example, and eventually we're going to make our own model of something in the real world, put it into a data structure, and then sort the items in our collection in different ways. Yeah, engines is a good idea. Okay, so anyway, we'll come back to that in a second after I sort of do the regular schedule rundown and stuff. So we are in week 8, so this is roughly the halfway point. We have 17 weeks, so for your class, we don't have a final exam. We just have 17 weeks of content, so it's not an even number of weeks, which means that really after we cross through next week, then we've broken past the halfway point. So week 8, we're doing vectors, and then we're going to make structs and make instances of that struct type and create a collection in a vector of instances of that struct type. And then we'll use the standard library sorting routine to sort our instances in a variety of ways. That's what your lab's about. The team projects due on Sunday, so hopefully you've been talking to your team. If you're not hearing anything from anybody at all, please let me know so we can do something about that, so that at least you can get credit for the team project. But what I would say is just everybody do your best, and we'll see how it goes, and we'll make sure that the larger number of us felt like we got a fair deal at the end. It's not a super hard project, so even if you have a member who's not showing up, it's probably not too big a deal. But let me know if you're completely alone on the team project, and I will do my best to work out something for you, even if it means that I need to either put you in a different group or join you myself as a member of your group. So anyway, do stress about getting it done, but don't stress if you are not finding a good teamwork in your team. We will work it out. Yeah, or possibly do whatever the digital form of twisting arms is. So it's not a huge one, so if you have one person who's never showing up, it's probably not that big a deal. If you're completely alone, though, please let me know, and I will do something to work with you to get that settled out. And then note also that individual project 2 is coming up on November 1st. That's quicker than we'd like it to be. That's pretty soon. So I will tell you that individual project 2 is a combination of the lab you're doing this week with the lab that we did 2 weeks ago, where you loaded data from a file. So what individual project 2 is, you're going to have a struct, you're going to have a class that manages a collection of instances of that struct, and then you're going to have code that loads data from a file. populates instances with the data, and then it puts those instances into a collection. So I'm going to try to build up an example over the next couple weeks to do that, but that's sort of the big ones. 6, 7, and 8, labs for weeks 6, 7, and 8 are the ones that you need to do the second project. So make sure that you use those as a reference. They were designed to give you all the skills that you need to do the second individual project. Okay, so week 8. So we're going to implement a struct and functions attached to that struct. We've done this before. In this case, we're going to do them as comparisons. And I think it was Joseph maybe who emailed me and pointed out that my comments, that it would be helpful to have more comments. So if you see that there's extra comments in there, it's because one of your classmates contacted me and I updated the starter code for this week to include a few more comments in it. So anyway, we're going to have a struct and functions. We've done that before. We're going to use a vector, and what we're going to do is we're going to create a class that contains a vector. Hopefully I'm going to have time to do 2 examples of that while we're sitting here tonight. And then inside of our class, we're going to implement CRUD operations. CRUD is just what's the word I'm looking for here? An acronym to remember the basic operations on a data structure, which is to create, read, update, and delete. So I will tell you as I'm doing that here in just a moment. And then we're going to use the standard library sorting routine to actually sort the contents of a vector. And hopefully I have time to do a simple example and then a slightly meatier example. I thought I would have supplemental lectures. Let me pop open the videos page. Or not. Oh no, I guess I didn't catalog or save any into a library for this week, so it's all about what I do tonight, so I'll be mindful of that. Okay, so the lab, which I'll come back to here in a moment, and I'll just step through and make sure that we've all seen everything for the week. So the discussion is really just to have you think a little bit about what I mean when I say CRUD. We'll use that as a reference point in the remainder of the semester. To talk about, if I have a collection, what kind of functions should I implement around it? And CRUD is a good place to start. Oh, that's why Baby Doll. So Baby Doll says that last semester there is a lecture for this part of the semester, but I changed up the lab. I guess I decided I didn't like the way I did it last semester, so I made a new one. And I'll talk about CRUD as I go. And then reminders, the team project on Sunday. It's not huge. And then pretty quickly after that comes the second individual project, which at first glance seems hard, but there's a whole lot of repetition in it. So once you work out one view, the rest of them I hope will come easy. So yeah, I guess I did change up the lab because I wasn't happy with what I did last semester apparently. Okay, so lab 8. Actually, I don't need lab 8 yet. Let's just switch to REPL and build up some examples. So I'll create a new REPL for myself. C++. I'm going to call this Number Manager. Now I'm calling it Number Manager because I want to sort of get you thinking about the meaning of the code that I'm writing here. So what I'm going to do is I'm going to create in my code a class whose job it is to manage numbers. That's it. So that's what we're going to work with. Now I'm going to do this in the fully object-oriented way, which means I'm going to have to switch between tabs a little bit. So I'll try not to go too fast, but I am going to be switching back and forth a little bit between tabs. So I'm going to add a new file here and call it numbermanager.h. That will be headers. And I'm going to add another one and call it numbermanager.cpp. So I'm doing it in the fully two separate files object-oriented way. And then I'll come back to main and I'll implement a program that demonstrates how it works. Okay, so I'm going to implement a class called numbermanager. And the way I do this is I start with the .h file. Blank screen, so I'm in numbermanager.h. I put a pragma statement at the top. This is a protection against what's a pretty common occurrence, which is you have an include for the same file in more than one location in a big project. And this pragma once guarantees that the compiler won't attempt to compile it twice. If the compiler reads a section of code twice, it's going to emit errors because it thinks that it's seeing duplicate variables and duplicate definitions of things. So this pragma once guarantees that no matter how many times I do an include for numbermanager.h in my project, the compiler won't emit errors because of it. I know that I'm going to use a vector in here. So I've included vector, and then what you see me do a lot on your labs is a more precise type of using directive. So I often do this because I want you to know precisely what it is that I'm using from the standard libraries. So I could say namespace standard and achieve the same goal, but I'm using this other setup because that's a little bit easier for you, I think, to realize that, oh, from this include, he's using this item. Some includes have items that don't look like they came from that include. I'll show you an example here in just a bit. So I'm going to use the include the vector library, and from it I'm using vector. So I'm going to create a class. It's going to be called numbermanager. Don't forget the semicolon. I've been doing that in the last few days on my ray tracer program. Forgetting that semicolon, and you get errors in the next file over if you do that, so try to get in the habit. Okay, so we're going to have some public functions, and we're also going to have a private data member. The private data member is the collection. I'm just going to make a vector of integers and call it numbers. So the idea here is that I'm creating all of this code to offer to someone the ability to manage a collection of numbers. Now that doesn't seem like I should write a whole bunch of code just for someone to do that, but you'll find yourself doing this pretty often, especially in this class. You will create a class like numbermanager whose job it is to manage the data coming in and going out of a collection inside. So numbermanager is actually a manager of a vector of integers. This class's job is to make sure that numbers can go in and numbers can come out. So we'll start with the C part of CRUD, which is create new entries in my collection. So any good number manager should accept an incoming number and add it to the collection. So we're going to do that first. We'll say, and I'll call the function add number, and it will be an integer. So this is the create entries in my collection function. So that's this class's entire job in life, is to offer functions that work on this vector somehow. Okay, so that's step one. I'm in the header file, and we're going to flip back and forth a little bit because I'm going to go implement this add number function right off the bat. So I'm going to go over to Number Manager. I'm going to include the header file so that I pick up all of the declarations. And then I'm going to create the implementation of this function. So remember, you have to do this scope resolution thing where you basically remind C++ that this add number function was first declared in the Number Manager class. But the whole problem, and this is where it can be sort of hard to track, I'll just flick over real quick and remind you. So I'm going to go back to the .h file. I have this numbers vector here. So in my implementation, I'm going to be doing things to the numbers vector. In this case, I'm going to add a number to it, and with vectors, you push back. That's how you do it. You push back. And that's it for starters. So that's the C part of CRUD. I have created a new entry, basically, in my little database of numbers. And that's really what Number Manager is doing, is sort of is being a database of integers. Okay, so I usually start with the create part, because if you can't add new entries, then there's no sense in having the Number Manager class in the first place. So I'm going to create one of the read functions, which in this case is not going to read a specific piece of data, but it's going to read or retrieve a piece of information about the database itself, which will be how many numbers are in there. So this is my header file. I added a new function header for a getSize function. I'm going to copy that and go back to my CPP file. And get ready to implement my function. So I'm playing a little bit fast and loose with the CRUD rules, but the way I tend to teach it is, so CRUD, CRUD, is an acronym that we use to remember the major operations on data structures. So the C part is to create new entries, which is what we did with our add number function. That is the create part of CRUD. The read part, the R part of CRUD, is, I just tend to think of it as the functions that I use to read information about the collection. So the size of the collection is one way to read information about the collection. So, oops, I don't know if anyone should have caught me there. We'll get the size, we'll return the size of my vector. So not everyone's going to understand what I'm about to say, but my Number Manager is actually wrapping functions around vector functions. So when some other programmer says add number, the reality is that inside of there is a pushback on a vector. And when some other programmer does a getSize, the reality is that there's a function that actually pulls the size of the vector that's inside of here. So some people would call these wrapper functions. So now I can get the size. I screwed up, by the way, here. So let's be better than that. In fact, this is going to be an unsigned integer. So getSize should return nothing less than 0 because you can't have a negative size vector. I need to flick back over to my header file .h and change the return type there to be unsigned int. Alright, so I'm going to pause a second, make sure I'm doing okay. I think I'm doing okay on time. This is my header file. So Pragma 1's at the top. I've included vector because that's what Number Manager does, is it actually manages a vector of numbers. I have this using directive, just so I don't have to put std : every time I want to refer to a vector. I have a C part of the CRUD function. I have one part of an R part of the CRUD functions. And then the private data member is the vector that is the thing that I'm actually managing. So that's my header file. Don't forget the semicolon. The CPP file, the implementation, has an include for the header file, and then it has the implementations of the two functions. And if you were following along, just make sure that you changed get size to return unsigned int in both files. I accidentally put void. So I can create new entries by receiving a number and pushing it back onto my vector, and I can read at least one piece of information about the collection, which is how many numbers are in there. Now let's go do some minimal implementation in main. So I am going to use the catch-all using directive in here to make things go faster. Now, the other thing you're going to want, I usually put it at the top. We're about to write a little code to test our number manager, so I'm going to include it here. And then I'm going to make one. I'm just going to call it M. This is a very Go language style to use these single letter names for things. It's not necessarily the best idea, but I'm in the habit now. So M is the name of my number manager instance, and I should be able to say, I should be able to fire off a read, the read part of CRUD on my number manager, and it should tell me that there's 0 entries to start. So there's 0 entries to start. Let me make sure you can actually see that. You can, okay. So 0 entries, and that makes sense because I haven't added anything yet. So now let's go add a few. So they're integers too, so I can put whatever I want. So I can add a 10. I know that what that number manager actually does, because I wrote it, is it takes that 10 and it tacks it onto the back of a vector. But the idea here is that any sort of normal programmer using my number manager class, they don't really have to know what happens. As long as the number doesn't get lost, that's all they're going to care about. If I add 10, is it there? Is it still there later? Let's add a few. They're integers, so I should be able to add negative numbers as well. I'm going to add 5 of them. They're just semi-random ones. Alright, so there's 5 numbers being added, and let's check the size and make sure it should report back to me when I read that piece of data about it that there are now 5 entries in it. And now there's 5, as we wanted. Okay, so we're on our way with the number manager. So this is a simple example, and we're going to do a slightly more elaborate one because that's more like what your lab is. Okay, so let's go back to the header file and add a few more functions. So get size is one form of read. Another form of read would be to get a number at a specific index. So this is another form of a read function, is that I can, given a specific index, I can retrieve the integer value at that index. So hopefully you know by now that vectors are very much like arrays. and you can access the data in them by index value. So that's another read. Let's do an update while we're at it. So to update a number, I'm going to need to know the index it's at and what number they want to change it with. So the U part of CRUD, update, means that I can go into the collection and alter a piece of data that's already in there. So in this case, if you give me an index, I will go to that index and replace the value there with the specified number. That's the U part of CRUD. The D part is to remove an entry, and I'll show you how that works with a vector, but you know what? Maybe we should return what we remove. So given an index, I will remove the element of the vector at that index, but I will also return to you the value that has now been removed, just as a confirmation. So there are other ways to do these things, but there are a set of CRUD operations. Create an entry, read information about the collection, read information about a specific element in the collection, update an element in the collection, and delete an element in the collection. So we're going to go implement these three. In numbermanager.cpp. I usually don't carry the comments forward unless I need them for reference. But these are fairly simple, so I don't. And let's do this part. So hopefully everyone's kind of observing my process, and you may decide that it's not a good process and use a different one, but at least you've seen one process. So notice that what I did when I brought the function headers over, the first thing I did was clean up. Good question. So the question is, do the update and delete functions need to have anything passed by reference, and they don't. So it's a very good question, but in this case, because Number Manager kind of owns a vector, it can make changes internally. So it's actually making changes to its own collection based on these function calls coming in. Okay, so get number. So we're just going to return numbers.at the index. This is not bulletproof. If they give a bad index, it's going to crash, and we don't have time to, we will fix that in the near future, but for now, let's just assume they're not going to make a mistake. So there's another read where really I just fetch them a value at an index. Updating a number. Is just going to the vector at that location and overriding it with number. So it's excellent that Little Peeper's thinking about where we might need references in this case, and this one does take some getting used to. Because the Number Manager kind of owns the numbers vector, there's no need for references here. The Number Manager can just sort of receive this request, as it were. Please update this number at this index with this new number. And internally, Number Manager can just alter the vector that it owns inside of here. Let's see. This one is a little tricky. Here's what it looks like for vectors, though. So we need to grab first thing we need to do is grab the value being removed. And then the way that you numbers.erase, this looks kind of funny. And then we'll return what we removed. So before I erase anything, I want to get what I'm about to remove out. So I make a copy of it. And then the way you eliminate things from a vector is the erase function on the vector, but then you have to do this little bit of math where you say, well, from the beginning, how far over is the thing that I want to remove? So that's how you do it, is numbers.begin plus an index. This has some power. We're not going to use it tonight, but there's some power in this because I don't have to start at the beginning. I can sort of subsection off a very large vector if I wanted to, but for our purposes, whenever we remove something, we're just going to go to the beginning and then shift over from there to find that specific index and erase that element. Then as the last step we do is we return what it is that we removed. So there is a fully CRUD operation number manager, which is actually a manager of a vector of integers on the inside. So it's not many functions. The whole idea of this, though, is when I go to implement a program, the program ends up looking a lot simpler than the code that's actually doing the work. So I can do things like what do I want to do? What did I add? Oh, I added another read. I'll put a label here. So my functions sort of read a lot more like English than the vector code itself does, which is one nice thing about writing classes like this. Might as well get another one while I'm at it. Say index 3. So there's me using the other read function, the CRUD part. I have an update, so I can do a m.update number. So if I, let's see, 0, 1, 2, I'll update the number at 2 with the value -5. And then I should be able to read that number. And get confirmation that it's actually been updated to be a -5. I haven't done a delete yet, so we'll try that. But let's just see if the numbers make sense. So there's the 10 that I expect at index 0, there's the 42 at index 3, and there's the updated value at index 2, which used to be -99, is now -5. So I sort of confirm that those functions work. So let's, what do we want to do? Do we want to print it out? Yeah, let's do one more function. I would consider this a read type function. I'm going to need some includes for it, which is a pain in the rear, but let's do it. I'm going to need string streams. I'm going to need strings. Now I'm feeling lazy, so I'm going to switch over to a catch-all using directive. So I've added includes for stream and string, and probably a lot of you know what's coming when I do that at this point. So I'm going to add another function here. This is kind of a read type function because it's allowing me to view information about the vector. A toString function, we've done several of these. But it can be very handy to have a function like this so you can quickly observe what's going on. Okay, 634. Let's do toString. I forgot to copy it. So I think everyone's seen this part before. So the question is, when should we use the catch-all using directives versus the more specific ones? Unless your team lead or your teacher or your boss someday cares, use whichever one you prefer. So in my real coding, I actually use the more specific using directives because I consider it a form of documentation. You can go read my using directives and see specifically the specific elements from libraries that I'm using. So I use it as a form of documentation, which this catch-all using directive does not do. You have no idea if I'm using O-string streams or I-string streams by reading this. So that's how I use them. That's my personal preference. So I would say until someone forces your hand, do whichever one you think is the most valuable to you. If you'd prefer to save the space, then just use the catch-all. If you'd prefer to get the experience and you like the way it looks, then use the more specific ones is what I would say. But the using directive itself, if you're using standard library stuff, then you're going to have this namespace in there. And as you get out in the world a little bit more, you will find that there are other namespaces out there. In fact, in this semester, I'll show you how to create your own namespace when we have some lighter day, hopefully, to work with. Okay, so hopefully that answered the questions about when to use these. Okay, so what was I? Oh, toString. Let's do toString real quick. So these are easy because it's a vector. So this is the way I like to loop through vectors. If I'm just fetching the data, then this is just super easy. And I will just take each number and follow it up with a space. So the one downside to this is that there's an extra space on the end, but who cares? It's one extra space. I'm not going to worry about it. So there's the toString. You've seen a bunch of these. I do them all the time because it is so convenient to be able to look at the data that's inside of your software. So I create these for myself a lot and try to sort of get you in the habit as well. Okay, so there's my toString. Now I'm going to go try it out here. So see what it looks like. And there's my values. They're just separated by spaces now. So 10, -3, -5 after the update, 42, and 7. Now I did that because I want to delete one and see what happens. So let's get rid of the 42, which is at index 0, 1, 2, 3. It's at index 3. We can actually print this out because it returns the removed value. So it should give us confirmation there that it actually removed it by printing out the 42 that we thought we removed, but I will do one last toString and confirm that in fact the 42 is not showing up in the larger collection. All right, here we go. So removing 42, so it returned the value that was supposed to have been removed back to me, and then when I did a toString on it, the 42 is gone, so it appears to have worked, which we're really pleased about. Okay, so now let's add some stuff. Let's add one more thing to this, and then we'll go on to a more elaborate example. Okay, so I am going to go to c++.com. and I'm going to search for standard : sort. Now their search is weird because they use Google, so weird stuff comes up, so you often have to kind of scroll down through the garbage at the top. But you'll notice there's a little separator down here. There's a little line right here, so I don't know what this is about, but the weird stuff comes up. Oh, there's why Planned Parenthood, because of the standard namespace. Anyway, standard sort's what we want. So anyway, if you do a search on C++.com, you often have to scroll down to the second section, standard sort. So we're looking for two things here. One thing is the include for it comes from algorithm. So I'm going to need to include algorithm. The other thing, and this is not going to help you tons until you see it, but I want you to see that there are examples down here. And in fact, look, their examples are written around a vector of integers. And then they are applying sorts to the vector of integers in various ways. So we're going to use this built-in sorting routine to sort the numbers in our number manager. So we need to include that. So I put all of my includes in the header file, in the .h file, and that's again because the .h file is kind of your documentation. So you put your includes here so that anybody who opens it up to see what you're doing will find your includes and whatever using directives you have. And the basic information, really, this is all they should need in theory to use your code. So we're going to add algorithm, and then I am going to create a new function here. I'm going to call it sort numbers. It's not a CRUD operation. It doesn't really create new entries. It doesn't read the entries. It doesn't update them. I mean, I guess it updates the collection, so technically you could call it an update if you wanted, because it is going to update the collection in terms of sorting the numbers. Now this is kind of a magic sort, meaning it just works. So let's go implement that. I didn't mean to run it. Okay. So I'm going to implement my sort routine on Number Manager. And the way you do this, sort, and then I happen to remember this, but you're going to recognize something from up here when I used begin. So numbers actually has a function built in that lets you go right to the beginning. So that's how you do this. You sort from the beginning to the end. Now you could, if you wanted to, sort some section in the middle of the larger vector by using the pluses and minuses and stuff, like the beginning +4 and then the end -3, and that would get sort of somewhere in the middle. But we're just going to sort all the way from the beginning up to and through the end. So this function, sort, is just auto magic, at least for integers. Now you're going to see where it doesn't work here in just a moment. Okay, so that is sort. We're going to go try it and see if it works. But this is the standard library sorting routine. And it is sorting my numbers vector from the beginning to the end. So now I'm going to go try out my sort numbers function. So back to my driver, I call sort, and then I print it out one more time. And they should be in order. And by default, it'll be descending order. I mean, ascending order. All right, so there's after the sort, they are in order now. The smallest number, -5, then -3, then 7, then 10. So the vector is sorted at the end, which I guess you could call an update type routine. All right, so we got to make this a little bit more interesting. But I'm going to give you a second to pause on that. So that is the most simple example I can do that's related to this week's lab, but I want to do one that is more like this week's lab, which is a little bit more elaborate. But not too bad. One thing I will tell you though, the reason why this sort just works is because integers are easy to sort. You can auto-magically sort floating point numbers, you can auto-magically sort strings, probably even bools if you wanted to. But you're going to see where this doesn't always work without a little bit of help. Okay, so hopefully it's okay for me to close this thing and open a new one. So I'm about to create a new REPL because I'm going to go through this whole process again, but with a slightly more complicated setup. Hopefully I'm doing okay on time. Okay, so that's just a class that has functions that allow you to work with a vector of integers. So let's do something more interesting. I'm going to add a new REPL. I'm going to call this one Shoe Manager because that's what came to mind just now for whatever reason. Okay, so same kind of thing. I'm going to create a couple of files. Shoe Manager.h, Shoe Manager.cpp, and we're going to go through the same thing. You can. So that's a very good question. If I have a component, can I select a specific field to sort on? And yes, you can. It's an excellent question. It's exactly what we're about to do is sort based on different fields. So let's do some of that. So start my .h file, pragma statement, which is just a protection against compiler errors. I'm going to have a vector in here again, although I also expect to have strings, and I also know now from practicing that I'm going to use the algorithm include to get the sorting functionality. We might as well include stream while we're at it so that we can to stringify our shoes if we want to. And then the big using directive. Okay. So this time we are creating a struct first to represent a shoe. Why a shoe? I don't know. It's just what came to mind. So we'll have a brand, we'll have a color, we'll have a size. I'll make it a float. Now let's just make it an integer, like the European style. Floats would work fine. I just not doing it. Let's see, brand, color, size. Well, we do want that though. Let's go ahead and do it. Size, float, price. All right, so there's our shoe. Now we're going to create a shoe manager class, semicolon at the end. The job of the shoe manager will be to manage a database of shoes. So we're going to have a public section, a private section. So now the vector is not of integers, it's of shoe, which I'll call shoes. So this is what Lab 8, this week's lab is about. Creating a database, in our case in the form of a vector, a collection to hold a whole bunch of individual shoe instances. And then writing CRUD functions to populate it. So we already know, for example, that we want to be able to add a shoe. So you're going to see me do something a little bit different with structs. Because structs are kind of bigger and more complicated, you can save the computer a little bit of work by passing in a constant reference to a shoe. So the whole reason to do that is simply because the computer has to do less work with the shoe, while still retaining the sort of safety that a copy would have otherwise. So we've already done that CRUD bit. We also know that we're going to want a sizing function, like how many shoes are in there. You know what all this looks like. Get a shoe at a specific index. We can remove a shoe at a specific index. So I'm kind of hammering these out faster because I don't want to make you sit here for an hour and a half again like I did last week. But there's a create, part of CRUD. Here's a read. Here's a read. Here's a delete. So I need an update. I'll put them sort of in alphabetical order. Void update shoe. So this one's a little bit tricky because when you're talking about a shoe, updating it could mean one or more of the fields. So what you'll often do when you're writing one of these manager type classes is you'll actually make functions to make it easy for someone to update different pieces. So we might say like update shoe name as an example. And then I'm going to do a whole series of these things. So update shoe color. So I'll have the index of the shoe in question and then the color that they want to update it to. Shoe size. Shoe price. And hopefully everyone understands that. Kind of the reason why I have the 4 different functions is because I imagine that someone working with my database may not be updating all of the fields of a shoe at once. They may just want to change the color or the size or the price or something of that particular shoe in the database. So I give them functions. So all of those are update functions, right? There's a whole collection, a whole set of them for the different fields inside of a shoe. Now for the manager, it has to know the index of the shoe that we want to alter, and then the data we want to alter it with. So if you call update shoe name, the shoe at this index is going to get this name overwritten on it. What else? We're going to want to sort. Sort shoes, and then we're going to want a, do I feel like doing it to string? I don't particularly, but I guess we should do a to string, because I know that's going to be time consuming. Okay, so hopefully everyone is doing okay with all of this. I haven't implemented any of these functions. You may have the sense that almost all of these are one-liner functions, so it's not a huge amount of code. There's actually more setup than there is actual code, the actual implementation. So I'm going to go ahead and make the leap for us. To do the shoe manager as a string, it would be very, very, very helpful if the shoe could be made to string as well. So I'm actually going to do that. So I'm actually going to give the shoe its own toString function, and then the shoe manager can use that. So that's a lot of code to go implement. So let's grab the shoes toString function. I'm going to copy that. I'm going to move it over to shoe manager. Include the .h file. Now this function was not declared inside of a class, so it does not get scope resolution on it. It's just a function that's out there that takes a shoe and returns a string. So it will not get scope resolution. All of these functions, however, come from inside the shoe manager class. I'm also memorizing the fact that my vector is called shoes. So I copied all of those function headers, and I'm going to put them in here. In my code, by the way, when I do this, like I have sections, sometimes I'll put just some kind of separator in here so that I can see the two sections, kind of. Hopefully this does Shift Tab. It does. And then before I start, I do the cleanup stuff. This is going to go well off the screen, so sorry about that. Alright, so there's all the brackets in place. Now all the shoe functions, which I pasted in below this line, they do need scope resolution because they came from out of the shoe manager class. And what I usually do is I type the first one out with the colons, and then I copy that, and then I go find the function names everywhere, get size, get shoe, update, 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 update. Yes, so there's a question in chat, should newbies stub functions? And yes, I would say that's a very good idea to stub functions like this. It's, to me, I've just found, I mean, this is just my own experience. I know that if I do this up front like this, I'm much less likely to forget one and make mistakes later. So I just do it right up front, even though I don't enjoy it. I just get that done up front. And then if you want to go through with the whole formal stubbing, that's a good idea too. Now we'll talk about that with everybody at some point, but yeah, it's a good idea to stub. Okay, so now they're all ready. We can sort of attack them in whatever order we want. I think I will attack them in order, so I'll start with stringifying a shoe. So I'm going to need a noString string for that. And then let's see, I'm going to get the shoes brand. I'm just going to do it like this. So brand, shoes color, comma, the shoes size, comma, the shoes price. Magic formula probably needed here. I don't have it. I haven't memorized it. I guess I could go grab it real quick. And then just change this to match up with my output string stream. That should be fine. I'll even put a little $sign here at the end. Okay, so that's turning the shoe into a string. All I really did is print out its fields, brand, color. Come on. size, and the price. I formatted it with the magic formula, and I separated it with commas so that it would look nice. Add shoe. We already know what that looks like. I take my shoes vector and I push back the shoe. Pretty easy. Getting the size of the shoe manager really means to return the size of the vector. Pretty easy. Getting a shoe is really just going to the shoes at an index and returning that shoe. So these are all one-liners is what I would call them. Updating the shoe's name. So that's a little bit more complicated, but I suspect what we can do is shoes.at the index. So the trick here is to learn to think in layers. If I go to my vector and I grab the single item at that index, I have a shoe. And if I have a shoe, I can use the dot to get its name, and then I will overwrite it with the name that came in as the parameter. So that's it. It's also just a one-liner to update that field. Same thing here. So I'll go to the shoes at that index. That gives me the shoe they want to update, and they want to change the color to be the color parameter. Updating the shoe size, same idea. Go get the shoe at that index, and then overwrite its size with the incoming one. This one's the price. So all those are pretty easy so far. Removing a shoe, we already know what that looks like. Although we are supposed to grab a shoe. Equals shoes.at index. So we'll grab a copy of the shoe. Turn that at the end, and then we will do shoes.erase. Go to the beginning and move over to that index, and that will erase that particular shoe. So still pretty easy. Sorting the shoes, I'm leaving that blank on purpose until we try out a little bit. Let's see what else. Hold on, let me do a block. Hold on, I'm doing a couple of blocks. Irritating. Yeah, it happens once in a while. Hopefully that's the end of that. Sorry. Okay, so I've been going kind of fast, but hopefully you're sort of noticing. Yeah, it's people who scripted that, isn't it? If you're watching the video later, we're getting some spam advertising chat messages. Okay, so hopefully everyone recognizes this is effectively the same code. Because I have shoes in here, which have multiple data fields in them, this was a little bit more complicated, but not crazy more complicated. Ultimately, I want to sort the shoes from the beginning to the end, but I know for certain that that's going to cause an error right now, so I'm going to set up for that, but I'm not going to do it. The shoe manager part, so stream out. So the whole trick here is to loop through the shoes database, grabbing the individual shoes. And then use that other shoe stringifying function that I wrote at the very top to take care of that work. Alright, so that should leave sort, and I'm going over a little bit, but I'm trying to sort of speed up a little bit so that I can get you out of here a little faster. Sort is not ready, but we need to go do a little bit of testing just to make sure that some of this stuff actually works. So we're going to go to main, I'm going to add a using directive here to make life easier. Include my shoe manager class. Create one and then start trying some stuff out. So how do I want to do that? I think what I'll do is I'll create a few shoes here, maybe just like 3 of them. Nike, red, size 11, price $99, I don't know. So I'm going to make myself a few shoe instances. Adidas, black, size 8. Those are floats, so I can make half sizes. I'll make those be, I know these are not realistic prices. They still make Pumas, probably still make Pumas. Blue. 6.5s, and let's make those. For some reason, those are crazy expensive. Alright, so now I have some shoes, and now I can add the shoes. Should print them all out. I don't have time to do testing on all the updating and stuff. I want to get to the sorting so you can see that. Let's run this and just see what we get. Remember name, oh yeah, it's not name, it's brand. That's line 29. Too many arguments to function call, expected 0. I can see that's going to be a problem. Okay, I'll fix that. Let's go do a few steps. So I'm going to go to storemanager.h. That name is conflicting with my toString inside of the class, so I'm going to change it to be shoe toString. So that I don't get that error that you see at the bottom from line 60. It's also the one at the bottom on line 3. And then also I have an error on line 29 that I know what that is. Okay, so I'm going to change the shoes toString function to be shoe toString. And then I got to go hunt that down everywhere. So at the very top, this is now shoe toString. And then I also used it once in my manager toString. I am stringifying a shoe in here, so that was the actual error I was trying to fix, is it was conflicting with the toString name. Okay, so now we'll call it shoe toString and hopefully everybody's happy. Let's go fix the error on line 29. That is brand. Oh gosh. That means the function name doesn't make any sense. I'm going to have to change that too. You might as well see me work through this though. So I don't have a shoe name, I have a shoe brand. So I changed brand. There's a whole bunch of brands in here. Update shoe brand, string brand, dot brand equals brand. There were 4 brands that I had to change in there. And now when I go over to the .h file, brand, and brand. It still would have worked, but with smaller changes, but I don't like badly named functions. Alright, are we going to get shoes printing out? Okay, so there they are printing out. The magic formula is working, so that's good news. And they are printing out in the order that they were added to the collection. So now let's sort them before we do the other stuff. So I'm going to go to shoemanager.cpp. And I'm going to comment in this sort. And when I do this, I'm going to get an error. So I'm going to run this, and I might even get a wall of errors. Okay, it's a wall of errors. Just all kinds of errors all over the place. A huge, gigantic wall of them. So I happen to know what this is, just sort of warning you that this can happen, this wall of errors. It's such a big wall of errors. Yeah, no, I can find the top. The green lines are actually kind of helpful because you see the line above it, it says shoe and shoe. So what it's telling me is shoe and shoe don't do this. Shoe and shoe don't know how to do less than. What does it mean for one shoe to be less than another? Now I'm about to show you how to fix that. Although, how do I pull this back down? No. Oh. But how do I get this? Like, I dragged this up here. Control, okay. Control, minus control. That's all right. The worst thing, but I lost the little handle on it, maybe. Oh no, here it is, way up in the right corner. Nasty. Okay, so this sorting thing does not work right now. And the reason why it doesn't work is because shoe is something I just invented, and it has multiple data fields, and it's really not possible for C++ to know how I mean to sort the shoes. So the fix here is to make a function that does that allows C++ to compare shoes with each other. So up here in the .h file, can I say plus? Yeah. In the .h file, I'm going to add a function that returns bool. I will compare them by brand. So what you have to do in this case is you actually have to create a function that allows C++ to compare shoes somehow. These functions will always return bool because what C++ is looking for is one shoe less than another. So I'm going to have two shoes here. And I'm going to start just with a compare shoes by brand function that returns a bool, and then I'll implement it so you can see what that looks like. So copy this, go to my CPP file. This one's going to go above the line at the top because this is kind of in the shoe section. Does not get scope resolution because it's not in a class. So when you are sorting custom data types like structs and classes, you often will have to create functions like this. So C++ wants to know what does it mean for S1 to be less than S2, and it needs to be able to work with data that it understands. So in this case, what I'm going to do is I'm just going to say, just compare the names. Not the names, the brands. So that function will return true if the first shoes brand comes before the second shoes brand in the alphabet. Strings can be compared that way. Oh yeah, I could have reloaded the page, that's true, to fix my little lost my handle thing. Okay, so here's a function. Given two shoes, it will return the result of comparing S1 with S2. By the way, I encourage you to switch that around and see what happens. But less than is the default that C++ is looking for here. So that's step one, is create this function. Step two is to go down to your sort call. Here it is. And you add a third argument. And you give C++ a function that will allow it to compare two shoes. And I just made one called compare shoes by brand, so now it should be able to do it. So that's the sort function where I added the third argument, which is the name of the function I just wrote that compares shoes by brand. Now we're going to go back to my main. I'm actually going to do a sort, and then I'm going to print it out again and see if they are in order by brand. I got to be careful about lifting this handle up too high. Alright, so there you'll notice the second output. It has now ordered them by their brand. Pretty neat. And I'll do a couple more real quick. Yeah, let me do one or two more just so you can see that repeated. So what you really want to do is, instead of having just one sorting function, you may want to offer multiple sorting functions, like sort by brand, sort by color, sort by size, sort by price. And then you have to make sure that your shoe can do that. So I'm going to make 4 of these. Sort by brand, sort shoes by color, sort shoes by size, sort shoes by price. Yeah, this is exactly what they do, right? When you go to most websites that have like lots of information like that, you can click the little arrows and they'll sort by a different field. Same basic idea. So to make this possible for the manager to sort the shoes by the different fields, the shoes have to offer the function to do that, and then the manager has to offer the functions to do that. So I'm going to grab those 3. I'm going to add them up at the top. And I usually do this part first. And then, let's see, by color simply means to compare the 2 colors. If you switch the operator around, you'll get descending order as opposed to ascending order. Isn't that cool? Here I will sort the sizes. And here I will sort the prices. So what C++ wants for its sort by default is a less than check on a specific piece of data. If you make it a greater than check, then you're going to end up with things going in descending order as opposed to ascending order, which is quite powerful. But most people are typically going to think ascending order. So there's all the shoe functions. This is the by brand version of this. Let me grab the others real quick. Those aren't them, these are them. No. Okay. Get these all worked in here. And then I'm just going to take this one and then change out the sorting function that it uses. So this is very, very powerful because the sort will still work. You just have to tell it how you would like it to be sorted. Okay, so now the shoe manager can sort by all of those things. Hopefully that's making sense to everybody. That's, I'm pretty sure, an implementation that mirrors the lab. You don't have to do, you're going to have a unit test instead of this little crude test that I did. Sort shoes by, so now I can try different things like by size, which should get them ordered by size. So you'll notice 6.5, 8, 11.5, and the other fields are kind of scrambled around. So that's the Lab 8 stuff. Let me look at the repo and see if there's anything else going on in there. Okay, so I think that you just saw a complete buildup from a blank screen to almost everything that you're going to see in the lab. So look, there's the sorting functions. There's a toString function, which is a little bit different. It's going to require some work. But most everything is the same. So I hopefully I left you with just enough challenge to be interesting, but not overwhelming. As always, you have a really good group of people to do Piazza on. So if you stumble on any of these pieces, because there's a lot of moving parts, get out there on Piazza, because the answers come quick and they're always good ones. So you're lucky to have that. I think that's it. Any questions or requests of me before I bid you a good evening? Okay, I can wait it out. Go ahead. We are. Are there overloaded operators in this? Okay, not yet. So there's a question, are we going to go over overloaded operators? We will when we encounter them. So yes, when an overloaded operator is required, I will talk about it. But I'm happy to work it in. So I'll put that on my shopping list for next week. And we will talk about overloaded operators at some point. We do have them in one of our assignments. By the way, if you're asking about overloaded operators, that is another way to get sort to work. If you know how to overload an operator, that's another option that you have. Yeah, so that's a good question. So, like, how do you figure out, like, what should my what should my functions be? What function headers do I need? What should the parameters look like? It's difficult to answer that in a short way. So, kind of knowing when to write a function and what the function should look like and what, if anything, it should return and what its parameters should be. That's kind of an accumulation of experience. So you have the experience of writing your own functions, you have the experience of looking how other people set up their functions, and unfortunately you kind of just have to accumulate experience around looking at functions and implementing functions and trying implementing your own, and eventually you begin to develop a good feel for how to make them, how to set them up, and what they should look like. Yeah, unfortunately, that's a lot of what this is. So, but I will, like, one short answer is CRUD is one example. So I knew what functions, most of what functions I was going to write for my shoe manager class and my number manager class, because I had the CRUD acronym in mind. So if you are dealing with something that's a collection, like a vector or an array, and we're going to deal with other collections as well, a good place to start is with the CRUD functions, and that kind of tells you, at least I need that set of functions to start. But that is takes everybody a long time to get good at function writing. Yeah, unfortunately. But But in this week, as an example, sort of be on the lookout for the CRUD functions, because I just as sort of I know that I'm going to probably have to write CRUD functions when I'm doing some kind of class that manages a collection of data. So that's at least one thing you can add to your toolkit. If you're managing a collection of data, you just automatically know the CRUD functions are going to be useful here probably. Okay, yeah, but I'm sorry that the answer is, it's a lot of it that is accumulated experience. Thanks. Thanks everybody. Have a good rest of your week. Get on Piazza. You've got good people. I check it every day, but normally by the time I've checked it, it's long since been answered. I left a couple of the functions that are in here. So the toString function in this inventory class is a little bit fancier than what we've done because it's got these numbers on it, so you have to be clever about that. We also didn't do a clear, but you're going to have to clear a vector, so that's easy to figure out, how to clear a vector. Okay, have a good night. Thanks for being here. Thanks for sticking it out this long. I hope that the extended examples are useful, seeing a little bit of the repetition and my thinking as I create them. So have a good night. Thanks, baby doll. I'll see you all on Tuesday next week. So take care.